In the previous video, we learned about functor in functional programming. If you missed that video, I strongly recommend checking it out. In this video, we will take a look at how to implement option, list, and either functors as an example, and you will see why functor is such a useful tool. Let's start by defining a simple function like strLength. So strLength receives a string and returns a number. So this function, what it does, again, it receives a string and returns the length property on the string. Let's try this. strLength ABCD. If we save, we get 4 on the right side. Our strLength function is pure, meaning for any possible input string, it returns a number. But imagine a situation where for some reason the input is not available. Like, for example, the input is coming from an API, but the API is broken. Or the input is a value of a property on an object, but the property is missing. Then we can model our input as an option of a string. But our function is not receiving option of a string, it is receiving string. One way to fix this is to re-implement strLength function. So let's do that. So our option of strLength, it receives an option of string and returns an option of number. Before doing anything, let's import all these types. And by the way, if these looks new to you, please check out my video on option. And let's import match for pattern matching. And I have a video, separate video for pattern matching. If this looks new to you, definitely check it out. So const, let's say strLength1 of type option strLength. What it does, first it's going to receive an input of type option of a string. Let's do, you know what, let's name this one fx2. And then we can do pattern match over this input. So fx, in case the input is absent, meaning it's none, then there is no string to check the length of it. So we can simply return none. Otherwise, if we have a value, what we can do is we can call strLength on that value, on that string, and then wrap that in sum again. Well, TypeScript cannot infer this type correctly, this string, so we need to help it. Let's try this. Console log strLength1 of type sum of a, b, c, d, for example. If I save, we get sum of 4. And if we do this for none, we get none. Another improvement that we can do here is we can redesign this point free, meaning that we can cancel fx from both sides. And we have the same thing. All right, let's define another pure function. This time, let's go with our good old increment function. Number, and it receives number and it returns a number. So const increment of type increment, it receives a number and it adds 1 to it. Let's say we want to use this increment function in a scenario similar to strLength, which the input can be absent. So type option of increment, the input can be option of number this time, and it needs to return an option of number again. So const increment 1 of type option of increment. What it does, it first receives the option of number, and now in order to do the calculation, we need to do pattern matching over it. So again, match. We do pattern matching over fx. If our input is none, there is no number. So we just simply return none. If we have a value, what we do is we're going to call increment over that value and wrap that again in sum. And you know what? Let's do this 0.3 again. And that's it. Let's make some space here and try this. Goes to log, increment 1, sum of, let's say, 12. If I save, we get sum of 13 on the right. And if I do console log increment 1 none, we get none on the right. Take a look at increment 1 and strlength1. They're pretty similar, right? And honestly, if you think about it, we are not asking much. We still want our strlength and increment functions to work and behave same as before. It's just we want them to be able to handle the absence of a value as well. This is where functors come to our help. Let's define a function that receives any function like strlength and increment and add support for option to them. Okay, let's make more space. And now let's define that. Let's call that function map of option. So map of option is a generic function that receives a function from A to B. So it's a generic function. We need to specify the generic types. It receives this function and returns a function that its input and output is lifted to option. So we have fx, that option of A, and returns option of B. So it receives this function from A to B and returns a function that receives option of A and returns option of B. Let's try to implement this. So map of option of type map option, it first receives a function from A to B, and then it's going to receive an option of A, and now it needs to return an option of B. How can we do this? We need to, again, pattern match. We need to pattern match over the input value. In case we don't have any value, same as before, there's nothing to calculate over, returning none. And if we have a value, then we can call f over that value and wrap it in sum. Again, TypeScript cannot infer the type of value, so we need to help it. We cannot simply say A in TypeScript here, so we need to do some tricks. We can grab this A from function f. So we can say parameters, and by the way, parameters is a type constructor from utility type constructors in TypeScript. We can say type of f, and it's going to return us a tuple of all the parameter types of a function, and we are going to say, give me the first one. And now the error is gone. The other option is we can get rid of all of this and make it 0.3, and now types looks okay. Now that we have our map function, we can simply pass our strlength and increment functions to map option to receive our new and enhanced functions for option context. So let's try this. Const strlength2, we can simply say map option, and pass strlen to it. Same for increment. Increment 2, you can call map of option on increment and receive our new function. Let's try our new functions. So console log strlen 2. Let's call it with sum of a, b, c, d. If I save, we get sum of 4. If I try this with strlen 2 none, we get none. Same for increment. Increment 2, sum of 12, we get sum of 13. And if I console log increment 2 with none, we get none. Well, we know functional programming is all about composition of functions. Let's try to compose strlen and increment. In order to do that, let's import compose. So compose, and if this looks new to you, I have a whole video about composing functions. Composed, yes. Let's go all the way down. So let's compose strlen and increment. Const. Let's call this increment length. We are first going to call our strlen over our inputs, and then we want to call increment over it. So if I console log this, console log increment length, it receives a string a, b, c, d, which has a length of 4. Pass that to increment, and it should give us 5, which we are seeing on the right side. Now, how can we lift this composed function to option context, similar to what we did for strlen and increment? There are two ways. So first, maybe we can do is let's define a function. Maybe we can simply lift each of the pure functions. So I'm going to lift increment function, and then I'm going to lift the strlen, and then I'm going to compose them. Another way can be, well, since increment length itself is a function, I can lift that function by itself. So increment length, here we go. What do you think about these two functions? Well, intuitively, we are expecting these two functions to work exactly the same. In case of the first function, we are lifting strlen, meaning that it's going to receive an option of a string and returns an option of number, and we pass that option of number to our lifted function of increment, which receives option of number and returns an option of number. The types are matching, so we compose them and return function 1. And in the second one, it's simply, it is already composed, right? It simply receives an option of string and returns an option of number. And that is what functor promises. Since option is a functor, composing the lifted functions is exactly same as lifting the composed function. Let's try this. Console log function 1 sum a, b, c, d. If I save, we get sum of 5 because the length of the string is 4 and we are incrementing it by 1, so it's 5. If we try the same with function 2 sum a, b, c, d, we are going to see the same exact results. Same for none. Function 1 none, we see none, and console log function 2 none, we see none. All right, let's move on to list, which is our next functor. First, let's make some space. We know how lists work. It can receive no or many values. Let's just for the sake of reminder, implement one list. So we have a list of a string, and our list can be like this: A. It's going to, the next element is B, the next element is C, and finally, end of our list. If this looks new to you, please check out my video on list. Let me import all the necessary types for list. Import list, cons, nil, and import match from lib list.ts. And since we have conflict of naming, let's rename match to something else. Let's rename this to match list. All right, let's go back. All right, let's define a map function to lift any function like strLength and increment to list context. So after lifting our functions, those functions type should look like this. So we have list of strLength, which receives x of list of string and returns list of number. For the increment, we say list of, for example, increment. It receives a list of number and returns a list of number. The idea is we don't want to re-implement strLength and increment again for list type constructor. We want to be able to reuse as much as possible. Let me comment these parts. So let's try to define the map function. So map list, it first receives a function from A to B, and we want to lift it and return a function that first receives a list of A and returns a list of B. This is a generic function, so we need to add those generic types, A and B. Let me move this down to make it look better. All right. The implementation of a map list looks like this. Map list, it first receives a function f from A to B, then it's going to receive a list of A, and now we want to do a pattern matching. So match list over fx. In case our input is nil, meaning we are at the end of our list, we're simply going to return nil. In case our list is not empty, we're going to have a head and the rest of its list inside tail. We're first going to call our f on head to receive b, and then we're going to create a new list. What do we do for the rest of the list? We're going to call map list again with our tail. Again, TypeScript cannot infer the types, and simple fix for this is to make this point free by canceling the same parameter from both sides of our equation. So map list go through all elements in the list and apply f to each value and returns the new list. All right, let's try this. Let's lift strLength to list. strLength 3 map list strLength. If we try this, console log strLength 3, let's say with the list one that we defined above. If I save, we get this output, which is not easy to read. So let's add show list function that I implemented in the list demo video so we can display list values better. All right, now if I save, we are getting 1, 1, 1. If I change this to, for example, BB and CCC, if I save, we get 1, 2, 3. Now let's lift the increment function to list. So increment 3, map list, increment. And let's go to log this, go to log, show list, increment 3. And what do we pass to it? Let's pass cons 1, cons 2, cons 3, and nil. If I save, we get 2, 3, 4. What increment 3 is doing is it is incrementing each of the values inside our list. Again, as you see, without changing the implementation of strlength and increment, we are enhancing those functions to work in the context of a list. How about either? Either wraps two types. How can we define a map function for it? Let's try this. Let me first make some space. Let's try to define a map function, which lets us to lift any function to an either context. So either receives a function from A to B. So the first thing is we have two generic type parameters. What this map either function does is that after it receives this function f, it returns a function that receives an either and returns an either. What should we put in these brackets? For optional list, both of them wraps one type, but either wraps two types. As you remember from the previous video, the way we can convert the first either to the second one is by partially applying and fixing the first type parameter. Let's say this fixed type parameter is a generic type E. So we're going to pass E as is without changing it. And let's add that E to our list of generic types. And now what we can do is we can say we are converting the second type parameter from A to B. All right, let's import all this stuff that we need. And by the way, if this looks new to you again, I explained either in detail in its own video. So either we need right, we need left, we need match, and let's rename it right away, match either from lib either.ts. So const map either of type map either. It first receives a function, then it receives an either of E and A. And what we want to do, we want to pattern match our input value. In case fx is left, then we have a left value. And what we want to do is we want to return that as is, because we don't know how to convert it. But in case we have a right value, we know how to convert it. So we first call f over that value and wrap it in right. TypeScript has a hard time inferring the types, so we can cancel the same type parameter from both sides and make this point free. Next, let's lift our increment and strlength to either context. So const increment 4 we can say map either of increment. If we try this, console log, increment 4, we say right of, for example, 12. We get right of 13. If I try this with left of, for example, let's say error, we're going to see a left with a value of error. For strlength, let's do the same. strlength 4. Let's lift this to either context. strlength console.log strlength 4 right of, for example, again A, B, C, D. If I save, we get right of 4. And if I do the same, increment 4 left of, for example, error, we get left of error. All right, now the question is, if we could define a map function for option and list, which both receives one type parameter, and either that receives two type parameters, can we do this with type constructors with any number of type parameters? If we try to do this, our generic map function should look something like this. It has two generic types and a bunch of others. It first receives a function from A to B, and then it returns a function that first receives a dynamic type constructor with at least one type parameter of A and returns that same type constructor, but converting the last type parameter from A to B. As you see, in order for our generic type constructor f to be functor and have a map function, it needs to wrap and receive at least one type parameter. But this is not a valid TypeScript syntax. And f should be parameterized as well. We will learn how to do this when we get into higher kinded types. But for now, thank you for watching this video. Please like and subscribe, and I will see you in the next one.